Thank you for joining us today. We have another amazing show and a fantastic guest for you today. Have you ever considered how we might find alternatives to traditional vertical rockets for spaceflight? Well, our guest has spent the last several years thinking about that very thing. Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, James Penna. He is the co founder and COO of Wave Motion Launch. Welcome to the show, James.
Good to be here, Lisa. Thank you.
Absolutely. Maybe we can start by having you just give a little bit of background on yourself and Wave Motion Launch.
Sure. Wave Motion was started in 2020. We're actually coming up on our 6th year anniversary very soon. It was started by myself and my co-founder, the CEO of the company, Finn Van Donkelaar. When we were in grad school, he one day invited me over to his house to show me this little launcher prototype that he had built. It ran off of blank gun cartridges and sent stuff to supersonic speeds. And when I looked at it, I thought that here is a novel propulsion solution that I don't think anyone else has ever seen. And several years later, we kept working at it. We worked through grad school. We both got our degrees. We didn't end up dropping out like a lot of founders do, but just through that, ended up getting the attention of the military, first through the Office of Naval Research, who said, "Hey, we want you to build a really big prototype to see if you can use this to replace artillery." And then from there, we continued the research with the Army on a direct to phase 2 SBIR project. And now, currently, we are focusing full steam ahead on space launch, which has always been our first goal as a company, our first love, and our ultimate big, hairy, audacious goal is building a launcher to send objects into space for extremely cheap prices at extremely high cadence.
Wow, that is amazing. So we spoke about 3 years ago now, which is amazing that it's been that long. And it sounds like you guys have come a long way since then. Can you talk about some of the improvements you've made to the jet gun and specifically talk about, I guess, modifying the design so that you're using solid particles to move at hypervelocity? Is that right? I don't know if I got that right.
Yeah, you've got it right. And I don't blame you for not knowing if you did or not, because like I said, it's a totally novel method. There really isn't any analogous process to this. So we've had a little bit of a branding issue, I suppose, the last few years, because initially our launcher device, the jet gun, used a gas jet. So our initial thought was that we were going to launch things over a very short path at very high acceleration to very high velocities, um, over a short period of time. So that looks more like a traditional gun. That looks like some of the launchers that are being built today by other companies that are doing what's called kinetic launch. Um, but we quickly discovered, both through our own research and during the Office of Naval Research project, that gas jets simply can't extend far enough to really give substantial acceleration. There was a whole bunch of other problems with parasitic mass, the fact that you need to intercept a gas flow which spreads out, which means you need a huge area. Um, it would have been really contrived to make a version of that technology that would be able to accelerate something to orbital speeds, if not just downright impossible.
Sure.
So and by we I mean mostly Finn, went back to the drawing board and thought about what we were really trying to do, which is transfer momentum. So going back on the jet gun itself, why it's different and why it's important is, compared to other kinetic launchers, compared to other methods of sending things to very high velocities for the purpose of shooting them into orbit, the jet gun doesn't enclose the projectile in any path. So there's a company called Longshot that's making a multi-stage accelerator they have to build a tube that's a couple miles long and has these injectors at each place. There's another company called General Hypersonics or Hypersciences. I'm not sure what they're branded as right now. They're doing a RAM accelerator cannon that needs to have a long tube of baffles that again stretches for miles and miles to get to orbital speed. What makes the jet gun so attractive as a concept is that you wouldn't have any sort of structure as your object accelerates. You'd just be pushing it from the ground from one small discrete device. So going back to that concept, we thought, well, if you put in solid particles, then that's transferring momentum in the same way that a gas molecule transfers momentum when it hits something. um, so instead of just relying on gas molecules, which will eventually mix with the atmosphere, if you put in these solid particles and they accelerate to very high speeds, then that doesn't slow down in the same way. You can have, if you're solid particles, and we're not talking about like muons or anything like that, or it's not particle physics particles. We're talking grains of sand, little spheres of steel or aluminum, things of that nature.
Huh.
Even plastic or wood we're experimenting with currently. Um, so if you take tiny particles or macrons, as we used to call them, and accelerate them in a gas flow, they can persist and travel a much farther distance than a gas flow can. And so now you get the hundreds of meters and kilometers that you would actually need to send something to very high velocities. And at a high enough power level, we think that a jet of these particles, a stream of these particles, would be able to penetrate through the entire atmosphere and into space, which would allow something to accelerate to orbital velocity. And here's the kicker, is that compared to our previous design, which had a very short path, so had to accelerate something like a gun, this will actually be a lot more of a rocket-like acceleration profile. So to my knowledge, we're the only kinetic launch concept that would be able to launch payloads without modification or even humans one day.
Wow. So that was going to be one of my questions, but I want to go back for a minute because you mentioned doing some Earth-based projects.
Hmm.
How has that played into, I guess, the design, this newer design for the jet gun?
Right. Well, we butter our bread from military funding, uh, in the most part, and really we see it just as a logical extension of the research that we need to do to get into orbit. Right. In the same way that a gun or a rocket engine is a propulsive device class thing, a jet gun is also a propulsive device class thing, right? So it can be repurposed in the same way that there are some people that are building very, very large guns to shoot things into orbit. You have people that build guns to shoot things at bad guys. So our military research is focused on that. Is skit was with lower velocity versions of the jet gun that would be used in indirect fires or for launching smart munitions, because there's a lot of advantages that the jet gun brings over regular guns, even smaller, lighter, less blast overpressure.
Interesting. So now I do want to get into kind of where you were headed a second ago, and that is, when you look at the advantages of the jet gun and talking about, I guess, the payloads themselves, right? When you were originally talking, I was thinking, oh my gosh, what sort of specialized packaging do you need to have for your payloads in order to withstand this, I guess, different sort of launch process? And it sounds like maybe not as much as I might have thought. So can you talk a little bit about that?
Sure. Yeah. Ultimately, we don't think it was a viable business model to expect customers to harden their payloads. And to be honest, the sorts of payloads that would be acceleration resistant in bulk. So think bulk materials like metal for construction or water. There's really no near-term market for that. I hate to say it. The space economy is progressing very rapidly. but it's not going to change overnight. And we're certainly not at the point where we need to be launching millions of tons of stuff into orbit to build orbital colonies and lunar bases and things like that. So, in the next 10 years, 20 years, really for a viable market, what we would want to do is to have those acceleration profiles as low as possible. So that way, customers could just launch using our method without having to go out of their way to redesign things. Now, that's a shame because the jet gun actually does allow you to use a totally different philosophy for designing spacecrafts, because now you're not burdened to making your payload as light as possible to squeeze out functionality. You have to do that with a multi-stage rocket because of the need to carry your propellant as you go, and the payload being a fraction of that propellant. It's the rocket equation. When you're
Right.
just chucking something from the surface of the earth at very high speeds, then you're not beholden to that same equation. You're already going almost as fast as you need to get into orbit. So instead of spending your budget mass on a whole bunch of steel for your fuel tank and then one little payload capsule like in Starship, you can now spend your mass budget on building things out of aluminum instead of titanium, or using riveted steel instead of, exotic fused composites or whatever. So your spacecraft design can actually change, but there would be no need for it to change compared to other kinetic concepts that do launch at hundreds or thousands of Gs. So that was a very important breakthrough for us. And again, what enables that is the fact that solid particles can travel coherently in a stream for a much farther distance than gas can. And the analogy that I like to make is that it's the difference between a drag race and getting onto a highway on ramp. Is that in a drag race, you're thrown back in your chair, you're accelerating very fast over a short distance to get to that high speed. Whereas if you're going on a highway on ramp, you have a longer distance, so your acceleration to get to that same speed can be a lot less.
Yeah.
So
Yeah.
you have a much gentler force over a much longer path that extends hundreds of kilometers, or even thousands, and that would enable you to lower the acceleration.
Okay. Can you talk about I guess, the capabilities in terms of weight and mass and all of that that can be launched via, I guess, a single launch? What does that look like?
Sure. So uh, we actually have an interesting problem with the jet gun. Not really a problem, but a feature you can call it, where the power you would need to get through the atmosphere to extend that acceleration path is so huge. We're talking about tens of gigawatts, which is the output of an orbital rocket thrust, right? If you were to actually calculate the power that's coming from like a Falcon Heavy or something like that, it'd be in the tens of gigawatts. That constrains us really to only launching very large payloads.
Huh.
So we're not actually looking at like the small sat market or sending small payloads. We are looking at super heavy lift, hundreds or even thousands of tons of payload to orbit. Sounds ambitious, but we like what we're seeing so far in the results that we've had. Um, so, yeah, instead of having, for instance, a titanium space capsule that's very, very thin and has like this ceramic heat shield, you could instead have just a capsule that's made of sheet steel, and on the bottom, because you have solid particles bouncing on this thing. In fact, I wish I had remembered to bring some artifacts to show. I won't get up now, but um, you do end up getting wear and erosion from the solid particles on whatever you have. So you would have to have a shield of some kind. But now that shield can be a giant block of steel that has water cooling running through it, right? So again, the design philosophy is totally different from what you would see in standard spacecraft. Um, because you'd have all that mass to play with compared to a huge multi-stage rocket, again like Starship, where every ounce of payload has to be carefully calibrated because you have so much mass going to fuel tanks, so much mass going to just the fuel itself, the oxidizer and the propellant.
Yeah, 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 I get it. S Overall, what is the advantage to launching from the ground, and I guess why is the jet gun better beyond, like, a conventional launch multi-stage rocket?
Right. It's that same reduction in complexity that you get in the design philosophy, right? When you have, it's exactly what we see. I know I keep talking about Starship, but it's the most exciting thing going on in space these days for sure. Until we really start rocking and rolling later this summer, then we might see. But
Yeah.
um, for decades, the design philosophy behind rockets has been everything has to be exquisitely engineered, right? Every ounce counts. And the constraint on that is imposed by the fact that rockets have to carry all their fuel with them. So if you have a facility on the ground, now, all that complexity that you would need to have in designing, let's say, a rocket engine, right? A rocket engine is a very exquisite machine. Each blade and a turbo pump is carefully calibrated. Each duct, each pipe, the thickness of each section of the combustion chamber. It's all very precision engineered. And beyond being precision engineered, it's also got to be light enough that it's not going to drag the rocket down, right? Like it has to be as light as possible. So you have
Sure.
all these exotic materials that you need, like Inconel and titanium and heat resistant copper alloys. Um, the ground facility, on the other hand, when you have something on the ground, you can just use steel. You can just use any, alloy that you want. You can use the cheapest stuff available because if something goes wrong, it goes wrong on the ground where it's repairable as opposed to going wrong, 50 kilometers in the sky.
Yeah, yeah, yeah. So, speaking of that, what does it take what kind of space do you need for the, I guess, launch facility itself?
Right. So a launch facility would basically just look like a natural gas farm almost, or a holding tank, or I don't know what you would really call them, but I guess a depot. It would look like a gas depot of some kind. You'd have large tanks of fuel. You'd have large tanks of oxygen. It would almost be like a rocket fueling depot, like you'd see at Boca Chica or at Vandenberg or something. Um, but instead of going into a rocket, it would go into the launcher itself. Because again, the launcher, the jet gun, is like the rocket engine, so you just have all those fuel tanks on the ground. Um, so
Yeah,
it'd actually be a pretty small footprint. It'd be comparable to what you would see at a normal rocket launch pad. Now, people think about particles falling down and going on their heads, as they bounce off. So you would still need to have a clear flight path. But luckily, in the United States, you're kind of mandated to fly over water anyway.
yeah.
So, and that's also why we were looking at like biodegradable particle materials like wood or ceramic or something like that for that environmental impact. Because again, it's the fact that the physical equipment compared to the acceleration path is so small, right? So it's
Yeah,
not
yeah,
it's not like a gun where you have to have this tube that's miles long. Or I know there's a company that's that's proposing an electromagnetic accelerator that would have to have a track that's miles long. Whereas the jet gun itself would be, a few tens of meters in length at most. It'd still be a pretty large machine, right? But it wouldn't be miles and miles of real estate. It would just look like a natural gas depot. You'd have your tanks of oxidizer, tank of fuel, tanks of particles, of course, and then the jet gun itself, and your launch tower and all that accoutrement.
got it, got it, got it. Okay, so where are you now in terms of your technology readiness level or your TRL level? Where are you? How close are we to, like, a first launch?
We're a lot closer than you'd think. So for our military technology, we're at a little higher TRL level. I can't disclose exactly where, um, because of critical defense knowledge. But for our orbital version for the space launch, I would say that we're burgeoning on TRL level 5. So I think that's integration and validation in a laboratory. So the non nerd answer to that is that we're going out this spring and summer to actually perform those first test launches.
Excellent. Wow, that's amazing.
So we have a prototype. If people are following us on LinkedIn or on YouTube, we have a prototype that we've built and we've started cold firing and testing. Um, but the we haven't yet fueled it. So we're going to go out and do our first fully operational field tests using fuel combustion within the next month or two. And we are working on a prototype launch vehicle as well. So our goal is by the summer to accelerate a vehicle into the air a little bit under FAA flight ceiling for now. We are actually also but for a high altitude launch, we are actually filling out an FAA Part 101 um, for amateur launch. So later this year, as soon as later this year, we might see a launch into, let's say, stratosphere several kilometers up, just as a proof of concept, right? So that's what all of the rocket companies did beforehand, is that they built hopper versions, right? So
Yeah.
SpaceX, um, their starship started with the famous flying water tank, right? And Stoke Space, which is another local space company, of course, um, they have some grand ambitions, but they started too with just a hopper prototype that was able to show their rocket engine concept working. So that
Yeah.
would be this prototype that we have. And then again, talking about the size, talking about the real estate that you would need for one of these systems, the one that we're planning on doing these demos with fits in the back of a truck.
Oh, wow.
Mhm.
Fantastic. Okay, so thank you so much for making time to be here today, James. If someone wanted to learn more about wave motion launch, what should they do?
Sorry about that. Um, they should first visit our website. We're always in the process of updating it. So that's wmlaunch.space. Um, we do have an email info box. So that's info@wavemotionlaunch.space. Um, and just keep your eyes peeled too. As we keep going into the year, this is really the year where we're going to show what this technology can do and bring out its full potential. So yeah, keep watching, and follow me on LinkedIn too. Follow Lisa on LinkedIn. That way you can get more great insider information like this.
Absolutely, absolutely. Well, thank you again for making time to be here today. It's been amazing seeing how far you've come in the last few years, and I'm really excited to continue to watch the development.
Yeah. I mean, last time I gave this interview, I was in a bedroom. Now, in a proper office with a shop floor and everything. So
Fantastic. Well, congratulations on all the progress. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.
all right, thank you for having me, Lisa.